Hello, I welcome you all in this third lecture on the program on joining technologies for the metals. In the last lecture you have seen the need for classifying the joining processes, and now in this presentation we will see what are the different factors on the basis of which joining processes can be classified. So, since there are two categories, means that there are two broad categories based on which the processes can be classified. One is like say technological factors and another is approach being used for joining purpose. So, these technical factors are like whether the filler metal is used or not, is one. Then second is the source of energy, whether electrical energy is being used, mechanical energy is being used, radiation or any other form of energy is used. And then third is in technical factors the source of energy, then whether there is a fusion or the pressure is being used. So, and then one more classification or the basis, which is arc or non-arc processes. So, these are the four technical factors on the basis of which the different welding processes are grouped and the classified. Another one, the approach of developing the weld joints involving like say use of the cast weld processes, where it is expected that molten metal will be fed from the outside for developing the joint. Then there is a fusion welding processes, where the melting of the fin surface is achieved for developing the joint and achieving the metallic continuity. And the third is heat being generated through electrical resistance heating. So, resistance heating, electrical resistance heating like in resistance welding processes, and then whether it is pressure or fusion welding, it is based on the actually whether the process is a solid state joining process. So, basically this the fourth classification or the fourth factor is here fusion, and here the solid state joining process. So, cast weld process, fusion weld process, resistance heating based process, and solid state joining processes. So, one by one I will talk about the different the factors, and the processes fall in the different categories, and their the suitability to put in that particular category, and what are the related controversies, or you can say the problems related with the classification in of putting the particular process in particular category. So, like the filler based process, the classification of the different processes based on the filler, like there are two categories where no filler is used. Those processes are categorized as autogeneous welding processes, and when the filler is used, then based on the filler, like the filler is used, the filler can be of the composition same as base metal, or it can be the different from the base metal. So, all those processes, like initially the gas welding was the process which was the only process where in joining of the thin sheets by melting the fin surfaces, through the flame of the gas used to be achieved, and this process was categorized as a autogeneous process. But later on, development of the, like say, the laser beam welding, electron beam welding, and where, like say, the melting of the fin surfaces can be achieved, and without development of without applying any filler, the joint can also be made. So in this category, earlier there was just the gas welding, but the development of the laser welding and the electron beam welding processes, which also do the same thing like melting of the fin surfaces to develop the joint, also fall in the same category. So this classification was not found that fit, like defining the processes as autogeneous welding just for the gas welding, but there are so many processes where autogeneous weld is made without addition of the any filler metal. Like in this category, we also have the resistance welding processes. Then those processes which use the filler metal is optional. There are certain processes where the filler metal is used, or filler metal may be used, or filler metal may not be used. So we will talk first about the filler metal of the same base metal. When it happens, the filler metal of the same base metal, in that case the solidification of the weld metal is achieved only through the growth mechanism, because of the presence of the partial melted grains. Directly the liquid metal is consumed through the growth mechanism, and this kind of the solidification is called epitaxial solidification. But when the composition is different, the solidification is completed through the nucleation and the growth mechanisms. This is one case where, so in most of the cases, whether it is when the matching filler is used, the solidification is achieved through this way. Then you will see there are certain processes which do not use any filler, and certain processes where filler may be used or may not be used, and filler is used compulsorily, like the processes which use no filler or filler may be used, and the filler is used in any case. So there are three categories of the processes. So like if you talk of the resistance welding processes, the no filler is used, and similarly or the friction welding processes, friction welding, ultrasonic welding, explosion welding, ultrasonic welding, explosion welding. In these processes the filler metal is not used. So here some of these processes, either they are carried out in the solid state, or where the in the processes like resistance welding over the heating, either to the partial melting takes place, or the just softening of the metal is involved. So there are certain processes where filler may be used or may not be used. They are like laser beam welding processes, electron beam welding processes, even the thin sheets welded using the gas, tungsten arc welding, or the TIG welding processes, or the plasma welding processes. The filler metal may be used or may not be used. There are certain processes where filler metal is used in any case whenever they are applied. In this case the arc is established between the consumable welding process, arc is established between the consumable electrode and the base metal. So these processes like shielded metal arc welding, or is also known as a manual metal arc welding process, and the submerged arc welding process, and the gas metal arc welding process, this is also known as MIG, and the submerged arc welding process, shielded metal arc welding process, electro slag welding process, electro gas welding process. All these processes the filler metal is in any case is applied between the is applied during the welding. So, this is the kind of the grouping of the different processes based on the filler, whether the filler is used or no filler is used. This is the case where when just melting of fairing surfaces is involved. Otherwise, in other processes filler metal may be used or may not be used. So, this is the classification of the different welding processes or the joining processes based on the use of filler. So, if you see this classification is especially problematic in respect of the autogeneous weld, wherein the gas welding used to be known as autogeneous welding process, but subsequent development of the laser beam welding and electron beam welding also was capable to do the same thing. So, this led to the confusion over it. Then the source of energy is the another criteria based on which the welding processes can be classified. The source of energy is in the form of, like, say, mechanical energy, chemical energy, and electrical energy and radiation energy. So, these are the different forms of the energies which are used for the welding purpose or for the joining purpose. These are used primarily for developing the heat. So, heat which will be used either for the purpose of fusion or for the like, say, to facilitate the diffusion or for lowering the yield strength, like in the solid state deformation processes, or there is one more, electrical resistance heating, electrical resistance. So, this is also actually using the electrical energy only. So, these are the 3 or 4 different forms of the energies which are used. So, if you see the chemical energy uses the chemical reactions for producing heat, so that the melting of the fairing surfaces can be realized. Mechanical energy is used not just for developing the heat, but also for the deformation purpose, plastic deformation purpose, either at the surface layers or of the bulk material. So, basically this uses the deformation and the interfacial frictional heat. So, this chemical reaction for producing the heat, this approach is used in the processes like thermite welding and the gas welding, where the chemical reactions between the fuel gas and the oxygen are used for producing the heat, so that melting of the fairing surfaces can be achieved, and the thermite welding where the metal oxides are interacted with certain metals, so that chemical reactions take place for producing the heat. And in the mechanical energy, where the friction and the deformation both are used for producing the heat, and the deformation at the interface, and this approach is used in the processes like ultrasonic welding, explosion welding. Actually, this is used in explosion welding, also in the chemical energy process, ultrasonic welding, here the friction welding, and commonly known as friction stir welding, forge welding. These are the joining processes which use mainly the mechanical energy, and then the electrical energy is used in all arc welding processes, and the resistance electrical resistance, heating means the resistance, basically the resistance welding processes, like say the spot welding, seam welding, projection welding, stud welding, etc., and the arc welding processes, like the shielded metal arc, gas tungsten arc, MIG, metal in gas metal arc welding, submerged arc welding, etc., and flush wet welding, etc. So many processes which fall in this category. And then radiation in based processes, where the either electron beam or the laser beam is used for generating the heat for the purpose of melting the fin surfaces. So, if we see the except the chemical energy, all other forms of energy like radiation energy, electrical energy, all these come from basically the electrical energy. Electrical energy is converted into the mechanical energy, or the radiation energy is in controlled way for producing the heat and using in the different forms. So, here the problem is the origin in mechanical and radiation energy is in electrical energy, and while we are saying that the categorization as a mechanical use of mechanical energy and the radiation energy, these are the form in which the electrical energy is used for the welding purpose in the two cases is different, but the main energy which is used for generating the mechanical energy and radiation energy is coming from the electrical energy only. So, this is the problem related with this. Actually, it is the electrical energy only which is used in form of the mechanical energy or in the radiation energy. So, this is, you can say, the non-clarity side, wherein although the form of energy which is actually used is the mechanical and radiation, but these are also coming from the electrical energy. So, although process can be grouped like this, but there is a non-clarity in the sense that the radiation and the mechanical energies are being are coming from the electrical energy. So, it's not that right to say that they are of the using the mechanical energy or the electrical, the radiation energies. Now we will see the another classification based on the technical factor, which is the pressure or the fusion welding, arc and non-arc based processes. So, the first one is the classification based on the arc or non-arc based processes. All those processes where heat for the purpose of melting or softening is used from the arc, like say the arc generates the heat for basically fusion, and very rarely it is used for the softening purpose, mostly it is for the fusion purpose. So, so all those processes where arc is established for generating the heat for the fusion purpose, they can be put in this category, like sealed in metal arc welding, gas metal arc welding, submerged arc welding, tungsten GTAW, gas tungsten arc welding, plasma arc welding, like say similarly there is a carbon arc welding, and then electro gas welding processes. So, all these are the processes where arc is used for generating the heat, and all other processes where no arc is used, non-arc based processes like the friction welding, resistance welding, gas welding, thermite welding. So, all those processes where actually the arc is not used for can be placed in this category, but is still there. The controversies exist in case of the two processes. One is the flash butt welding, and another is the electro slag welding. These are the two processes were found to be difficult to be placed in either of the categories, like the flash butt welding or the electro slag welding. Why it is so? I'll elaborate that. Because in the clarity does not exist in terms of the way by which heat is generated in these two cases, or the purpose for which heat is used in these two cases. So, for that we need to see first the way by which these processes work in. So, flash butt welding, basically in this process one and there is one component, there is another component, and if the two are to be welded, so one is kept fixed and another is movable. So, the both are fed with the power supplies. This is one connected to the one terminal and this is another terminal, and when the one is movable is brought in contact with the brought close to this one and brought in contact with this. So, flow of current starts due to the short circuiting, and then you will see the flashes are generated. So, these flashes are there for very short period. This helps to, as I have said, for cleaning purpose as well as softening purpose. And once if it happened, then it is taken apart, and then it is forced using heavy pressure to hold them together, so that the joint is formed. So, basically these flashes are being used not for the fusion purpose, just primarily for, these are the tiny sparks, these are not arcs, these are flashes, or you can say sparks, which will be just cleaning the surfaces and maybe softening the butting end little bit, and once if it happened, then they are forced together. So, here these are basically sparks, not arcs or the flashes. So, it is difficult to put in either of the category, not the resistance. Normally it is kept under the resistance welding processes, but it starts with the flashes and sparks. But it is not that a stable arc which will lead to the melting of the fang surfaces. Similarly, in case of the electro slag welding process, also find it difficult to put in category of the arc welding, because the way by which heat is generated in this category, it involves the use of both resistance as well as the arc. So, for that we need to see just the little bit principle of this process. Here these are the components to be joined in the front view. This is the base plate, here it is full of the flux, granular flux, and our electrode comes here, it touches to the back plate, sparks are there. So, this arc helps to initially melt the flux. So, melting of the flux is achieved through the heat of the arc. So, heat of the arc is primarily in the beginning is used for the melting of flux. Once flux is brought to the molten state and sufficient pool of the bath is created, the arc gets extinguished and the flow of current from the electrode to the base starts through the molten flux, and so the flow of current through molten flux causes the electrical resistance heating I square RT. So, this heat is actually used for the melting of the fang surfaces of the base metal as well as of the electrode. So, here once the sufficient pool of the molten slag is created, the flow of current through the molten slag, a molten flux by electrical resistance heating generates the heat, and that heat is used for the melting of the fin surfaces of the base metal. So, basically the melting or the fusion of the fin surface of the base metal is achieved through the I square RT heating due to the flow of current through the molten flux, not due to the arc. But since this process starts with the arc for melting of the flux, and thereafter it is which is used for the melting of the fin surfaces. So, it is difficult to put in either of the categories, neither resistance welding nor the arc welding processes. Now, we have the other process like pressure and the fusion welding. In fusion welding, wherever the melting of the fin surfaces is achieved and the solidification of the molten pool is allowed under the normal gravitational conditions without any external force. So, if this is the case, then we will see that it is the normal fusion welding. Sometimes if the melting of the pool, if the molten metal is generated and then it is allowed to solidify only under in confinement under pressure conditions, then that is categorized under the pressure welding conditions. So, all those processes where molten metal is generated through the fusion of the fin surfaces, or means weld pool is produced through the fusion of the fin surfaces, and thereafter solidification takes place under the normal gravity conditions, that is categorized as a fusion welding process. And if either heating is done just for softening purpose or for deformation of the deformation at the interface, or deformation in the in form of the bulk deformation at the bulk level to have the metallic continuity using the pressure, or even if the fusion is involved, if the solidification takes place in very confined conditions under the pressure, then it is characterized as a pressure welding. So, pressure welding either involving use of the deformation, either bulk or the interfacial deformation for developing the joint, like ultrasonic welding processes, friction welding, all those explosion welding, all those will be coming in this category. Resistance welding processes, because here confinement, if even if the molten metal is formed, it solidifies in very confined situation. And the gravitational and if the solidification takes place under the gravitation condition, then it is categorized as a fusion welding process. So, our all arc, gas, arc welding, gas welding, thermite welding, in all those cases where fusion occurs under the normal gravity conditions, then they are put under the category of the fusion welding process. And others where the deformation is involved or the fusion is in solidification is taking place in very confined conditions under pressure, then that will be categorized as those processes will be categorized as a pressure welding process. This is most acceptable and a non-controversial kind of the classification by putting the process in the fusion or in the pressure welding category. Apart from that, there is another big group of the welding processes involving the approach of developing the weld joint, that is about so that classification involves the use of cast welding processes. So, welding processes like the thermite welding and the electroslag welding, they fall in this category. In thermite welding, basically between the components to be joined, the molten metal is prepared outside and then it is fed between the fin surfaces. So, this is typical the processes where just like in casting, the molten metal is prepared outside and then it is put into the mold for developing the weld joint. But it is not so in case of the electroslag welding. In case of the electroslag welding, the molten metal is generated between the fin surfaces itself, and then after solidification the joint is formed. So, this is the different than the thermite welding. In true sense, thermite welding is the cast weld process, but in electrostatic welding where the molten metal is generated between the fixed surfaces only, it is a bit different from the cast weld process, because in casting molten metal is not generated in the mold. So, same is not true for the electrostatic welding process. Then next, based on the approach of the developing weld joints, the fusion welding process, wherever the fusion of the fixed surface is achieved for developing the joint, those are categorized. So, all arc welding, gas welding, thermite welding, the gas welding, the laser welding, electron beam welding, wherever the fusion of fixed surface is achieved for developing the weld joint, they are categorized under the fusion welding processes. So, our all arc, gas, electron beam, laser beam, etc., all those processes where fusion is involved can be categorized under the fusion welding process. And then resistance welding processes where I square RT heating principle is used for generating the heat, are kept under this category. So, our all resistance spot welding, seam welding, projection welding, stud welding, and likewise there are a number of resistance welding processes which are put in this category. The basic idea is that wherever resistance, electrical resistance heating is involved for developing the weld joint. And then solid state welding process. Solid state welding process involve, there are two categories where in the low heat generation or the high use of high heat is involved. So, basically the solid state joining process, they will be using the deformation. Now, this deformation may be interfacial or it may be the bulk. So, in case of the interfacial deformation, the very limited heat is also generated. So, like in this category, like cold pressure welding, ultrasonic welding, explosion welding, mainly the interfacial deformation is involved, very less heat is generated, while lot of heat is generated and although very limited deformation is there, like the processes in use of the diffusion bonding. So, diffusion bonding uses the high heat to facilitate the diffusion. At the same time, your friction welding and friction stir welding based processes, all these use lot of heat, and because of that it is categorized under the category of the solid state welding processes with the high heat. So, in this presentation you have seen there are two basic factors based on which the different joining processes can be classified. One is the technological factor and another is the approach of developing the joint, and this kind of classification actually helps in to see how the different processes can be brought together or they can be separated based on the fundamental similarities or the dissimilarities. So, thank you for your attention for this presentation. In the next presentation, I will talk about the different ways by which heat is generated for joining purpose and the purposes for which heat is used, as well as thereafter the requirement to protect the pools for developing the joints. Thank you for your attention.